Good evening, everyone. Welcome to CML InfoTech. My name is Muhammad Ali. We're talking about IP version 4 from CCNA, day 4, part 2. Fine, we'll continue. So what we are talking about, the IPv4 total number, which we can write from 1 to 254. And these 1 to 254 are divided into class A, B, C, D, and E. So 1 to 126, 127 to 191, 190 to 223, 224 to 239, 240 to 254. So it starts from 1 and end up with the 254. So the IPv4 address are 4 octet. So when you see the first octet, you can address those are from which class based on the outcome. Let's say if I'm writing something, let's say 200. One second. So if I'm writing 200, any numbers like a 4 or 5, 6, whatever number. So the first octet, which you can see 200, which means it's a class C, because the 200 in between 190 to 220. The same if I'm writing, let's say 150, 111. You can see the 150, the first octet, the number in between 127 and 191. So this is class B. So you have a 4 octet to mention your IP address. So when you're writing an IPv4 address, let's say you have 4 octet, 1, 2, 3, and 4. You can write any number starting from 0 to 255 on every octet. Here also from 0 to 255, 0 to 255, 0 to 255. Clear? You can write any number in between 0 to 255, but only the valid IP in between 1 to 254. So, and you have the number which I mentioned from A, B, C, D, E. Let's say I'm writing a number or 75. Okay, 0, 0, 0. So the 75, which is in class A, because 1 to 126 is in class A. If I'm writing 175, what will happen? This is in 175 in between 127 and 191. This is class B. So this address will be referred as a class B. Instead, if I'm writing, let's say 215, which is class C. So when you have an IPv4, it's for you easy to understand which class it is while going through the first octet of any IPv4 address. Okay. Let's talk about class A address. Okay, the range from 120 to 1 to 126. Any class of IP, as I said, there are 2 portions, one called network and one called host. For class A, you have 4 octet. In class A, out of 4 octet, only the first octet will be referred as network, and the remaining 3 octet will referred or as host. What is the difference between network and host? That's the question. We'll come to know that. When I say network, which is on, okay? When I say host, which is off. Off in the sense 0, on in the sense 1. As I said in the binary, always calculation either 1 or 0. Okay. So now, when I say a network is 1, which means the network portion of the octet is completely 1. Here we have only one octet as a network, which is all bit within that.
அதுக்கப்புறம் கருவேப்பிலை காஞ்ச மிளகாய் இதெல்லாம் போட்டு நல்லா வறுத்து அதுக்கப்புறம் பேஸ்ட் பண்ணி அந்த பேஸ்ட் வச்சு இந்த ப்ரிப்பரேஷன் கம்ப்ளீட் பண்ணிருக்கோம். இந்த ப்ரிப்பரேஷன் சாப்பிடும்போது பாத்தீங்கன்னா லைட்டா மைல்டா அந்த புளிப்பு தன்மை அந்த காரத்தன்மை.
I request you to mute from your end. Unless if you have anything to discuss, you can unmute and discuss with me. Thank you. So here we have a one octet for the network for the class A. When I say class A, only one first octet in the network. When I say network, the first the network bit or the network represent is 1. 1 means on. So one octet as a network means the whole bit in that octet is on, which is 8-bit. 1, 2, 3, 4, 5, 6, 7, 8. And the host in the sense the rest of the whole bits is 8 bits is off. Okay. And when I say the complete bit is on, which means 255. Okay. When I say it's completely off means 0. So because of one only first octet, 1 octet is in network and the rest is off, which is 3 octet is off in class A, the output is called 255,000. This is also known as subnet mask. Okay. Then this all I'm talking about the piece of info. When we'll come together, then only we'll have a clear idea about the whole address. Okay. So maybe you have a questions. We'll keep within new, and once I finished, you can come back because your current questions will have an answer on the ongoing topics. Now let's say I have a class A number from 1 to 126. And if I'm writing 1, okay, and I said I can start from 0, 0, and 0, and I can end up with 255. 255. 255. Okay. Here I must write 1 because this is called network area. Network area. So in the network area, the 1 must be same for all other address. Here I can start like 1.0.0.1. I can start like 1.0.0.2. The way I can reach until the previous number of the last number, which is called 254, right? And 255, 255. But here still looks 1. So what does that mean? I'm writing 1, 0, 0, 0. And I'm writing 1, 0, 0, 1. I'm writing 1, 0, 0, 2. The way I can go down. What if I changed 2 from the place of 1? That's the question. Let's say I said this is only in network and this is host. So what's the difference within this? I need to make a network. The IP address is needed when you implement the network. Okay. I have, let's say 1, 2, 3. I have a 4 computer with me. I need them to be in the network. So I purchased a switch. And switch will have a port numbers. And the system will have an NIC, network interface card. This is PC, this is NIC. This is switch, and this is port 1, 2, 3, 4, 5, 6 ports. Okay, I've connected first NIC into this port, second NIC into this port. So let's say I connected to this port, I connected to second port, I connected to third port, I connected to fourth port. Do I need to continue 1, 2, 3, 4, or can I connect it to any other ports? It's a question that will come to know later. For time being, we are connecting to one of the first 4 ports into the first 4 systems. Now, I need IP into this system. How do I can assign an IP? Let's say if the 4 computers need to communicate to each other, then they must be same network. Same network, or we can call one network. Now the question, which IP you want to take it? Let's say IP version 4. And from the IP version 4, the question, which class gonna take it? Let's say I'm gonna take class A. In the class A, I have from 1 to 126. Which number should I take? You can take it any number. Let's say I'm gonna take the first one, number 1. So I need an IP to this computer. What IP I should give? As I said, the remaining 3 octet for the host. The host, whenever your number increased, like I said, 1, 2, 3, 4, any number, that will be make sense to increasing your system number, your IP address. But to become a same network, one network, your network portion must be same. Keep in mind and give a deep concentration on this area, please. Let's say the first computer, I'm gonna give an IP 1.0.0.1. Okay, and this IP shouldn't be 1001 because 1001 already assigned to PC1. So what is the next IP? I can give any different number only in the host portion to become a same network. But my network portion must be same in order to communicate between them. Let's say I'm going to give 1.0.0.2. So what is the difference between these two? The one on the first network and one on the first network here in the PC2 are same. So they can communicate each other. And to address a different system that I given 001, 002, but it is not mandatory that you need to give this way. I can give here 1.1.1.1, where I made a changes on the second, third, fourth octet. I given a different number than the previous given number, but the network portion I have given the same 1, 1, and the 1, because they are addressing the same network. And this system, I can give 1.7.220.254 because the second, third, and fourth octet, anything in between 0 to 255. But the first octet must be same because we are doing the class A, one network. Hope you understand. In this, I have a switch 2, 3, 4 PC. Class A 1 to 126. If I am giving here 1 dot, I have to give X, 4 digit. If it's class A, this is network and this is host. Host can be changed to get the more system into the network. If I'm giving here 1.10.20.3, okay, And here I need to add one more thing. In class A, only one octet in the network, which means 8-bit. Therefore, I need to define /8. Why I need to have a /8? Because class A having only one octet in the network. One octet means 8-bit. Now I need to assign an IP to the second system. I can give any digit in the second, third, fourth octet. Like for example, I'm going to give, let's say, there I've given 10, I'm giving 11, 20, 3, 8, and 1. So what we have changes in this. The second octet, here I have given 10, and here I'm giving 11. The rest is same. So any of the host portion area must be changed to have another system. If I'm giving here, like for example, 1.11.20.4, it's different. But always we recommended to assign an IP in the way of continuous address. Like for example, 1.0.0.1/8, 1.0.0.2/8, 1.0.0.3/8, 1.0.0.4/8. Like this is PC4. We can say PC1, PC2, PC3, PC4. 1, 2, 3, 4 are the IP from one network. So this 1001, 1002, 1003, and 4 all are IP. But in shortly, what I can write 1.000/8. This is network, and these are IPs. How do I define this as a network? So there is a clause on this. If host portion of IP address become fully or completely 0. If a host portion of the IP address, let's say 1001, 1.0.0.1/8. This I'm writing here. If host portion of IP address, so this is the IP address. Host portion of the IP address, we need to know which area is host portion in this IP. So let's say this is class A. How do you know class A? Because it starts with the 1. Okay. In class A, only one octet or 8-bit is on, which is network. So the remaining are host. Now I said, if a host portion, which is second, third, fourth octet of the IP address become completely 0. What do you mean by completely 0? The host portion is 0, 0, 0, which is the one network. Then we call it as network address. This is called 1000. Now the other clause, let's say, if host portion of IP address become fully owned. What do you mean by own? This is the host portion. If I'm writing completely on 1111111111111, all 8 bits is on. What is the decimal of that? 1.255, 255, 255, which is all 8 bit is on. The second is equivalent to the second. This third is equivalent to this third. If this is completely on, which is called broadcast. If this host sending a query to this number 1.255, 255, 255, that query will reach to everyone within that network. If a host 1001 sending data to 1003, this will go to only this computer, which is called unicast communication, one-to-one communication. If a host portion is completely on and sending to that address from one computer or one device will goes to everyone within that network, which is called broadcast address. Hope you understood. So when I say a class A, there is a network address, there is a IPs, there is a broadcast. Okay. As an example, if I'm writing 175, sorry, if I'm writing 75, which is class A, 25, 35, 200. What is this? And I must need to write /8, which will be giving an idea. This will be default class A. Because when I say 75, which is class A, only one octet is turned on, which is 8-bit. That is reflected here as 8. And when you write this 8, this is also known as prefix length, PL, prefix length. This is one of the IP in 75 network. And if I'm writing 75, 0, 0, 0, which is complete bit of the host portion within that IP become off, called network. If I'm writing 75, 255, 255, 255, 8, which means the host portion of the 75 network, they become completely on, which is called broadcast address. Okay. Let's say if I'm writing 35, which is in between 1 to 126, 35, 3, 4, 5. This is one IP for one of my computer. I have 4 computer connecting to one switch. This is switch. Okay, this is my system IP 35.345. If I'm writing here another IP 35, 3, 4, let's say 15. PC1, PC2, PC3, and PC4. Now my PC3 is 35, 3, 4, 5, 8. My PC4, 36, 3, 4, let's say 5, 8. Which all the system can communicate? 35, 3, 4, 5, 35, 3, 4, 15 can communicate or cannot communicate? It's a question. Yes or no? Yes means communicate, no means not communicate. Yes, this will be communicate. How many say no? Nobody. This will communicate each other because they are in the same network, 35 and 35, 345, 3450, different IP. What about PC3? 35345 and 35345. The PC3 and PC1 can communicate or cannot communicate. PC3 and PC1. No idea. Okay. When you try to assign 35, when a 35345, if I'm assigning to PC3, you will be getting a message that conflict or duplicate address. You cannot assign 35345 into PC3 because that IP is already assigned to PC1. Keep in mind, same IP cannot define more than one times or multiple times. No, one IP, one time, that's it. Okay. If you do not have IP on PC1, then the PC3 can be acceptable. So this conflict, this IP cannot give. So what you need to give, example, let's say I'm going to give any other number will be changed. It works. Now, PC1, PC2, and PC3 are communicate each other. What about PC4? The PC4 can communicate to other systems or cannot? Cannot. Yeah. Why? The reason why they cannot. Let's say I'm going to change 345 into, let's say, 1345. So the host portion is different. If you change the host value would be different. Still, they cannot communicate because in class A, the first octet must be matched. Here, 35, 35, 35, but here is 36. Therefore, the network portion of the any IP must be same on a multiple devices in order to communicate them each other. Hope you understood. Fine. You have a homework that you need to write 5 different network, and each network you need to define the network and the broadcast. Example, in 35 network, 35.0.0/8 is the network. 35.255.255.255 is the host, and you need to write 5 different IP in between that. Do not continue like a 35.0.0.1, 35.0.0.2, 3, 4, 5. Do not write like this. Make some changes in between on a different types. Okay. We'll talk about class B now. Class B. 127 to 191 is the range. In class B, first two octet for network, and the last two, give me a second please. So the last two octet would be host. What I meant that okay, I'm just giving a brief idea about the class A. The class A, we have same thing. In the class B, we have a first two octet in the network and the last two octet in the host. Fine. So which means 8, 8, 8, 8. So I said the first two octet in the network, which means if you're defining a single network, the first two octet shouldn't change, and the second two octet for the host. Okay. So class B, if I'm giving any address, for example, I'm giving 150. Let's say I have a switch. I have one computer. I have a second computer. I have a third computer. PC1, PC2, and PC3. I'm writing the first PC's IP. Let's say 150. I said the second, third, fourth octet, I can give any number irrespective of class. So I'm going to give you 1, 1, 1. Okay. Which class it is? Class B. In class B, how many octet would be in the network? The first two. The first two octet means how many bits? 16, right? 8 and 8. So I need to define /16. Okay. Now I'm writing the second system IP, which is again 150 and 1. The first two octet shouldn't be changed to define the network, because in class B, the first two octet in the network, I can write here anything. Let's say 1/2. Again, what I need to define? 16, because the first two octet in the network. The idea behind to define /16 in class B to address that the first two octet in the network. Okay. In the third system, I can write 150, 1, let's say 2/1. Here 1.2, Here I can write 2.1 because 1.2 and 2.1, the area where I changed is part of the host portion. For the 150.1, 150.1 in the 150.1, 150.1, and the 150.1, all the three systems must be same to define they are in the same class or they are in the same network. Okay, 16. I have a one more system. What if I write 150.2.2.1 or 2.11, whatever it is, the host portion can be changed. They cannot communicate. The reason they are not communicating each other because this area 150.2 and this area 150.1, they are the difference. Okay. Now, why should I need to mention /16? Or if I have a host which I have IP address in class A, which is again 1.0.0.1/8. What is the idea behind mentioning 8 and behind mentioning 16? So before I'm going to that, hope you understand the idea behind to define the first two octet for the same. Because in class B, the first two octet always address for network. Let's say I have a system which is 150.1.0.1/16. Okay, I have a system 150.1.0.2/16. Can they communicate or not? No reply from message. Yes, they can. How they can, or what is the reason for them to communicate? They are in the same network. They are in the same network, which means the first two octet are in the same. I have another computer where I'm trying to give an IP 150.1.0.1. The moment I'm trying to give this IP, they cannot communicate, or even I cannot give an IP, it's going to be conflict. We're going to have the same IP already. Now, the question they have asked, why do we need to define a 16? Because they are in class B, default 16. And one of the other reason, why do we always need to define the slash and the value of the on bit or the network bits? Look into this. I have another system like 150.1.0.1 slash, or let's say, I'm going to write in this color, define 150.1.0.1/24. They all look like same, or even I changed here, let's say 3 and different type. So 150.1.0.1, 150.1.0.2, 150.1.0.3, but look wise it's common 1, 2, 3 with the 151, but it's a /24, which means these two are 16, which means first two are in the same network. But here, if you look into the third computer, 150.1. It's a 24. 24 means 8, 8, 8, which is 24. So this system belongs to 3 octet in the network. They are being changed. This will be actually upcoming chapters, or even you could also see that 150.1.0.4. But look wise, this is the 4th computer within the same network. But even I can write /8, which is backward. So by look wise, they are the backend, means the different network. Okay. So what I'm trying to explain here, by default, class A always /8 and /B always 16 by default. But when you see any IP address, you should know whether they are in which class by going through the first octet. Let's say here I'm writing a system IP 10.1.1.1. Then this must be /8. When I'm writing 150, which is in class B, they must be /16. They must be /16. So by going through, when you're writing a default IP of any defined classes, they also define /8 or /16. But do not think always this would be the same. This 10 can be, this 10 supposed to be 8, but can be 9, can be 10, can be 11, can be 30, can be even 6, can be even 3. They could be a changes that will become an afterwards. But for a time being, what you need to understand, when you see any IP address, you need to understand that IP belongs to which class by going through the first octet. And if it's class A, you need to define /8. If it's class B, you need to define class B /16. Okay. Now, hope you understand these two areas. This is, we just explained about class A and B. So by going through this, you need to understand the class A 1 to 126 and class B 127 to 128, 127 to 129, 191, class B. And when we say class A, they must be /8. When I say class B, that must be /16. But there could be chances for changing it. Here I mentioned the bits as well. Now, we will discuss about class C. When we have all the 3 classes, then you will have easy idea about to understand about what is the difference between them. So hope you understand the session and very clearly about IPv4 class A and B. But of course, there could be more lab in order to understand in a practical way. Only when you start the lab can be easily understand. So I request you to join another session today itself for the part 3 for the closure of the session, inshallah. Thank you for connecting with us. I'm from CML InfoTech. Have a good day.